So the next topic is thermodynamic quantities. So thermodynamic quantities have three parts. Number one, a number. Number two, a unit. And number three, sign. So note about the sign. A positive delta E or positive sign result when the system gain energy from the surrounding. In example is endothermic. We have seen in previous slide that when delta E is positive, it means energy is gained by surrounding and the reaction will be endothermic. So energy is taking in. And if the delta is a negative, total in energy, internal energy, when the system loses the energy to the surrounding. So when system loses its energy to the surrounding, this delta E become negative, and the reaction is called exothermic. So let's see once again the same thing in a different way. So changes in internal energy. When energy is exchanged between the system and the surrounding, it is exchanged as either heat, Q, or work. So that is why delta E we can calculate work plus heat plus work. And here in this figure they shows that suppose if you have some internal energy which is you store in a save, and when you are adding some more internal energy in the system, basically you are working on the system and you are increasing the heat of the internal energy of the system. In that case, energy is deposited into system and delta E will be more than 0. Heat will also be more than 0. Work will also be more than 0. So this is called endothermic reaction. This type of system is called endothermic because we are putting more energy, we are increasing the heat, we are working on the system. And in the other system, when we take it out, internal energy from the system to the surrounding, so what will happen here? So heat will be lost and work done by the system, and in that case delta E will be negative, less than 0. So that is why whenever internal energy changes between the system and surrounding, it is expressed as total amount of work and heat and work. So let's see, we can summarize these in the form of table, that delta E, work, heat and work, and their sign. If Q is a heat, this is the heat, this is work, this is total internal energy. So if Q means heat is positive, means system gain heat, and if Q is negative, meaning system loses heat. On the other hand, if W means work is positive, it means work done on the system, and negative means work done by the system. Next is for delta E. If it is positive, it means net gain of the energy by the system, and negative sign means loss of energy by the system. So mostly negative sign means work is done or by the system, and positive sign means work is done on the system. So this is these were the about the sign and their interpretation. Next is about the work. What is the work? How to define this work and how we can calculate if the system is doing any work. So usually the only work done by the chemical or the physical change is the mechanical work associated with the change in the volume of gases. So in this picture it is shows that this piston have, this is the initial state of the piston, which have some gas inside, and here this is shows that P for pressure, which is equal to force per area, and when force was removed from the top, then work was done by this gas and the piston goes from initial state to above higher place. So this is initial state, this is the final state, and we can calculate the total volume change by finding the distance or height from this piston. So we can calculate the work done by the system. In this system, like gas is enclosed in the cylinder, this is initial state, cross section area is A, and final state is from here. So system does work W is equal to minus P delta V on the surrounding as gas expand, pushing piston up distance delta H. So this is the formula how we can calculate when a system which have a gas work on the piston and it changes its height from initial state to above. So we can calculate work is equal to minus P delta V. So which is pressure, P is pressure, and delta V will be equal to, you can calculate by area and volume height to find out the total volume of the cylinder. So in this example they have shown a real example how we can measure the work done by a system. So we can measure the work done by the gas if the reaction is done in a vessel that has been fitted with the piston, and W can be calculated based on minus P delta V, and the work is negative because it is the work done by the system. So let's understand this figure, what is going on here. So in this round bottom flask we have HCl, hydrochloric acid in the water, and when we add zinc solid in this one, what will happen, zinc solid react with proton of or H plus of acid, and it converts zinc into zinc ion, and hydrogen proton gain the electrons and they become like hydrogen gas. So if this closed system is fitted with this piston, and before starting any reaction, before adding zinc, the piston is at this point, and after adding zinc reaction happen, some hydrogen gas form, and that gas will go up and it will push this piston up to this height. So this height you can measure, and based on the height and the area of the piston we can calculate total volume change. So once we know the total volume, so increase in the volume means system does pressure volume work. So once we will know how much volume has changed, then using the atmospheric pressure, because here atmospheric pressure is applied, we can find out how much work was done by the system. So this was about the work and the sign of the thermodynamic quantities.